Weather and climate are often used interchangeably, but they represent distinct yet interconnected aspects of the Earth's atmosphere. Understanding their differences and interplay is crucial for comprehending the complex forces that shape our planet's environment. From the daily dance of sunshine and rain to the long-term shifts in global temperature, weather and climate are inextricably linked. Imagine you're looking out your window. You see sunshine, or maybe you see rain. That's the weather. It's what's happening in the atmosphere right now. Now imagine you're looking at a graph showing average temperatures over decades. That's climate. It tells us about long-term patterns. Weather and climate are like two sides of the same coin. They influence and shape each other in profound ways. By unraveling their intricate relationship, we can gain a deeper appreciation for the delicate balance that governs our planet's climate system. Weather refers to the state of the atmosphere at a particular time and location. It encompasses a range of atmospheric conditions including temperature, humidity, precipitation, wind speed and direction, cloud cover, and visibility. Weather is highly dynamic, changing rapidly over short periods from minutes to hours to days. Weather is what you see when you step outside. It's the sun shining brightly. It's the sudden downpour. It's the gentle breeze. These atmospheric conditions are constantly changing, creating the dynamic and ever-shifting tapestry of weather we experience daily. Meteorologists, scientists who study weather, use sophisticated instruments and computer models to observe, analyze, and forecast weather patterns. They provide us with valuable information about impending storms, temperature fluctuations, and other weather events that impact our daily lives. Climate, on the other hand, represents the long-term average weather patterns of a particular region or the entire planet. It encompasses not only the average values of atmospheric variables, but also their variability and extremes over extended periods, typically decades, centuries, or even millennia. Climate is the bigger picture. It's the average weather over many years. Think of it as the personality of a region's weather. Some places have hot and humid climates, others are cold and dry. Climate is determined by factors like latitude, altitude, and proximity to oceans. Climate scientists study past climate records, such as ice cores and tree rings, to understand how climate has changed over time. They also use computer models to project future climate scenarios based on different greenhouse gas emission pathways. While weather is often perceived as a short-term phenomenon, it can have long-term impacts on climate. Extreme weather events such as hurricanes, droughts, and heat waves can alter ecosystems, influence ocean currents, and affect the distribution of heat and moisture in the atmosphere, thereby influencing climate patterns over time. Weather can be extreme. Think of hurricanes. These powerful storms can cause widespread damage and flooding. Over time, frequent hurricanes can impact coastlines and change the landscape. Droughts are another example. They can lead to desertification, affecting the climate of a region for years to come. Moreover, changes in the frequency, intensity, and duration of weather events, driven by factors such as natural variability and human-induced climate change, can contribute to shifts in climate norms and long-term trends. Section 5. El Niño, a prime example of weather shaping climate. El Niño Southern Oscillation, or ENSO, is a prime example of how weather patterns can influence climate on a global scale. El Niño, characterized by unusually warm surface waters in the central and eastern equatorial Pacific Ocean, disrupts normal atmospheric circulation patterns, leading to widespread changes in precipitation, temperature, and storm tracks. El Niño is a climate pattern that occurs in the Pacific Ocean. It involves the warming of surface waters. When El Niño occurs, it disrupts weather patterns worldwide. Some regions experience heavy rainfall, while others face severe droughts. These changes can last for several months, impacting agriculture and ecosystems. During El Niño events, regions typically characterized by dry conditions such as the western United States and parts of Australia may experience increased rainfall, while regions accustomed to abundant rainfall, such as Southeast Asia and parts of South America, may face droughts. Section 6. Climate's influence on weather, shifting baselines. Climate, in turn, exerts a profound influence on weather patterns. As the Earth's climate changes, it alters the background conditions in which weather occurs. For instance, rising global temperatures due to climate change lead to warmer oceans, which can fuel more intense hurricanes and increase the amount of moisture in the atmosphere, resulting in heavier precipitation events. Think of climate as the stage where weather performs. Climate sets the scene. A warmer climate means a warmer stage. This leads to more extreme weather events. Heat waves become more frequent and intense. Storms pack a bigger punch. Droughts last longer. Furthermore, climate change can alter atmospheric circulation patterns, such as the jet stream, leading to shifts in storm tracks, changes in the frequency and intensity of extreme weather events, and alterations in regional weather patterns. Section 7. Global warming, a stark illustration of climate change. Global warming, the ongoing increase in Earth's average temperature due to human activities, is a stark illustration of how climate change can impact weather patterns. As greenhouse gas emissions from human activities trap heat in the atmosphere, they warm the planet, leading to a cascade of effects on weather systems worldwide. Global warming is like turning up the thermostat on Earth. As we burn fossil fuels, we release greenhouse gases into the atmosphere. These gases trap heat, causing the planet to warm. This warming effect has significant consequences for weather patterns around the globe. Warmer temperatures lead to more frequent and intense heat waves, increased evaporation, heavier precipitation events, and more severe droughts. Climate change is also linked to rising sea levels, which exacerbate coastal flooding during storms and high tides. Section 8. Understanding the interplay, key to a sustainable future. Understanding the intricate relationship between weather and climate is paramount for addressing the challenges posed by climate change and creating a more sustainable future. By comprehending how weather events influence climate patterns and how climate change in turn alters weather systems, we can develop more accurate climate models, improve weather forecasting, and implement effective adaptation and mitigation strategies. We live in a time of unprecedented environmental change. Climate change is no longer a distant threat. It's here, and it's impacting our planet in profound ways. Understanding the interplay between weather and climate is crucial for navigating the challenges ahead. Investing in climate research, promoting public awareness about climate change, and transitioning to a low-carbon economy are essential steps toward mitigating the impacts of climate change and ensuring a habitable planet for future generations. Section 9. Conclusion, Weather, Climate, and Our Shared Destiny.